Okay, so this is going to be a really quick video. I just wanted to make a note about decomposition. There's special cases. So if you have decomposition is when you start with, and this is just an example, you start with a compound and it breaks down, so decomposes, to simpler substances. Okay, so think big to smaller pieces. So if you have, let's say, decomposition, this is the special cases I'm talking about, decomposition of metal carbonates. Remember we talked about polyatomic ions, carbonate, CO3. So I'll give you an example. So we have calcium carbonate. CO3 is the carbonate, right? One compound. It breaks down to calcium oxide plus CO2 gas. Okay? And this is solid. And this is solid. So those symbols on the bottom just mean the state of matter it's in. So solid and then gas. So carbonate will always break down to a metal oxide and carbon dioxide. Okay? So you're always going to end up with the metal oxide. See how the oxygen didn't leave completely? You're tempted to want to say, oh, you end up with Ca and CO3. That's not the case, okay? That's why I'm making this video, so you know that there's a special case. So decomposition of metal carbonates, make sure that you make the metal oxide and carbon dioxide. And then the only other one I wanted to point out is decomposition of metal hydroxides. So hydroxide is OH. Okay, so if you have, we'll keep calcium, OH2, solid, and so this breaks down to metal hydroxides, break down so that you, once again, form the metal oxide. So in either case, you're always going to form the metal oxide, but instead of CO2, instead of carbon dioxide, you have water. Okay, so metal carbonates, you start with the compound, it breaks down to metal oxide and carbon dioxide. And when it's a metal hydroxide, the carbonate, it's metal oxide still, but you get water instead. Okay, so those are the special cases for decomposition.